Next week, we'll hear from Jonathan Bachrach of UC Berkeley. He will advise us how to eat robots. And that's next week. This week I have the good sense of inviting somebody who will introduce us to a brand new idea, which is temperament. Will explain everything. So Brian Thoms of CSU Channel Islands. Let's welcome our speaker.
Big room, haven't been in front of this many people in a while. So yeah, that's me. I'm down at Cal State Channel Islands. Anyone ever been? Old Mental Institute? Yeah, pretty cool. Right? I fit right in on the Mental Institute. Before that, I actually taught at State University of New York, and it was I taught in a morgue. I'm not even kidding, it was a morgue. So I went from a morgue to a mental institute. Stepping up in the world. So anyway, so this is a quick agenda. There's a lot of things to talk about. Got 40 minutes roughly, and then I'll kind of a minute and a half for questions, but no answers, just questions. So if you want to do this, I usually do this. I forgot to tweet it today. I'm a bit nervous. So just anything you tweet at hashtag socialxyz gets pulled into my system. I don't do the at socialxyz. I don't own it. I have the handle at socialxyz, but because it's a conversation, what I do is conversation-based research. I'll talk more about that. But if you tweet there, everything gets fed into my system, and people can see it. My students can see it, really. So anyway, we'll talk a little bit more about that. Oh yeah, I tell all my students. So you always have to worry about anything, any kind of public information you display online, whether it's for course or for your own friendly enjoyments. Just remember that the HR representatives or your instructors are digesting that information. So you can look pretty bad very quickly online, and nothing that you post online is gone. What was it? Instagram, not Instagram, Snapchat, right? Within X amount of time it disappeared. That's not true, right? I mean, as soon as it's online, someone has already downloaded it. They have all these systems that just wait for data to be produced, and they download it, store it in a database, and then eventually when you run for office, they use it against you. All right, so just a background on me. I'm a native New Yorker, so I talk really quick. I did my bachelor's out in New York City, and then I did my master's also in New York City, Fordham, and then Stevens Institute of Technology, and then I came out to California for the PhD. So I worked on Wall Street for about 5 years. My undergrad was during the dot-com craziness. So I don't know if you read your history books about the dot-com era, right? A lot of you probably experienced it, but some of you like when you were 5, 6, maybe even younger. Anyway, it was a crazy time to be. So that was like my education. My education was the dot-com. I wasn't in class, I was building websites. So I was getting paid well to just do all sorts of crazy stuff. There was so much money being thrown at anyone who knew anything about technology. So it was a really fun time to learn and being an undergrad. And then after that, I moved to Wall Street. So I worked on Wall Street for 5 years. Yeah, if you want experience, go work for the machine. I actually worked on an application that, again, probably history for a lot of you. They were very young, but it was based on the mortgage crisis. So I actually built applications that pulled those mortgages together, whether they were junk or they were good, pulled them together, and allowed people to trade it. So it's kind of crazy to be a part of that for a number of years. And then I said nuts to all that. I moved on to more altruistic areas. So I went out for my PhD. I call it I'm still paying my penance for my time on Wall Street. Probably will for the rest of my life. But I focus mostly on nonprofits now. So I build software for education, for small to mid-sized companies, and I also build for healthcare. We have our own healthcare platform that focuses on building software for underserved, underprivileged communities like homeless people and stuff around LA. We focus on community clinics and all that. So we're doing really good stuff there. What I teach down at Channel Islands is databases. So I'm heavy on data. I look at data, I analyze data, I build systems all centered around data, and how we can use that data to better interact with users, consumers of data. I teach internet social networks, internet-based social networks, and then I do data structures and programming concepts. I'm a programmer by trade. I usually always identify myself not by the company I work for, but the fact that I'm a software developer. I build code. I do everything around computing, around software development. And I just happen to teach it now. Yeah, and then health IT courses I teach also. So just going to go quick into the origins. So my research started in 1920, about 100 years, no, not 100 years, 7 years before I was born. 60 years before I was born. And you can't read the plaque here, but it just says, in summary, it says the center of a college is conversation. And that's kind of the whole basis of everything I do. It's building software that facilitates conversation. So I crossed out a college, so it could be anything. So the whole point is that you can as long as there's conversation, as long as there's something to talk about. I don't know. We have an artifact. I can build a piece of software that centers around it. Like you can look at Instagram, right? Is Instagram conversational? What features of Instagram make it a conversation? Does anyone know? You can talk. Say something. Hashtags and comments and things like that. I call those conversations. So any kind of interaction that's taking place over some type of artifact, whatever it is, that's a conversation. People are discussing it. Anyone watch the debate last night? You watch the debate with Twitter, with Twitter in your right-hand column, so you're watching the debate and then you see all the tweets that come in from various people, political analysts, friends, or whatever. That's where it gets interesting. You have two people who you'll never meet. Maybe you will meet them. Never meet or really or care to meet for that matter. But all your friends are providing a lot of content, a lot of feedback based on what these two individuals are talking about. So it becomes much more personal, much more interesting when you're directly involved in the conversation. I'm sure you get to cast your vote, so make sure you go cast your vote in, was it 20 days, less than 20 days? Anyway, all right, so I started this research back when I first began my PhD in 2005. And the idea was, all right, well, if we're going to talk about conversation, and I was part of the social learning software lab, so if we're going to talk about conversation in an academic setting, I think we're all familiar with these types of tools. What's the course management tool here? What do you use? You use Moodle. So I don't have a picture of Moodle here because I've never used it in an educational setting, but I have Angel, which is owned by Blackboard, and CI, well, we call it CI Learn, but that is Blackboard. And their course management software. They rebranded themselves as learning management software, which is fine. But the question that I asked 10 years ago, or over 10 years ago now, was how conversational is this software? If we say, especially schools like Sonoma State, Channel Islands, and my previous institution, a couple of my previous institutions, we call them student-centric universities, meaning that students are the primary focus. But the software that we've been interacting with is not student-centric. It's actually, it helps facilitate the class. It's used for instructors to be able to kind of manage the classroom. And there's very little focus on creating creating software that is engaging for students. So that was kind of the idea. That's reason number one anyway. Reason number two is just the market for e-learning systems is huge. It's not as big as, has anyone ever taken a marketing class yet? A marketing class? Marketing is a $600 billion industry. Much smaller, but it's still a big industry. It's $60 billion. So learning management systems like Blackboard, massive system. The nice thing about Moodle is that it's open source. And a lot of what I do is based on open source software. So you can take something like Moodle, open it up, and tweak the way it looks. And that's kind of what I do. So I can't work with the institutional software like Blackboard because they close it off. I can't just download the software, open it up, and make it more engaging for students. I'm stuck with what it looks like and tweaking the interface through their admin platform or something. But when it's open source, I can download it, I can open it up, and I can tweak it, make it, and see what it can do with it, kind of perform experiments. But it's a huge industry. And the third piece is I'm in STEM discipline. Are most of us in STEM discipline here? Are there any not in STEM? Still applies to you, but everyone knows what STEM stands for, right? Biology, right? STEM? No? What does it stand for? Science, technology, engineering, and math, right? So there's a couple statistics up here, but BLS stands for the Bureau of Labor Statistics. So the field is projected to grow. I mean, there's more need for STEM majors than ever. The problem is that most STEM majors, most students that enter STEM disciplines just drop out. It's hard, right? I mean, it's pretty hard. But they don't realize, and it's frustrating because when I was an undergrad, it was hard. I majored in computer science. The first time I was ever introduced to abstract data types and things like that. So it was a completely different approach to thinking. And you're thinking in your head, like, oh, wow, this is hard. And then you look at the person next to you, and they're just like daydreaming, so they kind of look like they know what's going on, like the look on their face. So it looks like they understand everything that the instructor's talking about. But in truth, they probably are just as lost as you are in certain concepts. So it's really frustrating that a lot of people drop out because they don't have a social network. They don't have wow, when I was an undergrad, I had a group of, I wouldn't even call them friends. They were friends, but it was more we were friendly because we were all struggling with the material. So we'd meet every week, and we would BS along with learn about what we needed to learn. So it was a great community of just peers that were able to get together and kind of figure out the material. But sometimes a lot of folks, and depending on what culture you come from, some cultures work alone, other cultures work in groups. So it's important to have tools that are out there that can facilitate some kind of social interaction and make things easier and to learn from. So anyways, that's reason number 3. So I love this quote. It's old. It's like 16 years old. Anyway, this is Jeannie Priest. I think she's somewhere up around here. I don't know if she's working for Microsoft right now. She was at Berkeley for a while and then Stanford. She's bounced around. She's huge in the field of, we'll see it on the next slide, human-computer interaction. That's my specific domain of computers. So this is what her quote was from 2001. And software developers can control the design of a social network, online social network, but it's difficult to control interaction. So her point was that just because you build something doesn't mean that it will yield the levels of interaction you want. I just stole her words, literally stole it, all those same exact words, and just reversed it and just said, yeah, it's difficult to control it, right? It's difficult to control interaction. That's in a classroom, unless of course you have someone that says, shut up. People will be quiet and listen. But lots of times it's really difficult to control interaction, but you can control design. That's what I was born to do, I guess. I love building software. I love building software for users to see how they can kind of interact with something. So yeah, so I'll take her words. Wow, that's pushing 10 years, that quote. Anyway, all right, so this is the field of computer science that I focus on. There's Priest. She's got way more sight. This was, I think I did the screenshot a few months ago, but she's widely cited, huge figure in this field of human-computer interaction. That's just a very, this is how I do definitions, by the way. I don't even go to the source anymore. I just do a Google screenshot and take the definition, paste it in. It's just a fun way to kind of get definitions. That's from Wikipedia, who probably took it from somewhere else. But specifically, it just is how can we build computers? How are computers interacting with people? That's all it's about. What can we do to facilitate the interaction that people have with computers? That's what I do. And for the past 10 years, this was the initial theory I developed using technology, it's activity theory, constructivism, focusing on individuals, and then community. So those are the 3 areas I look on: the technology, the individual, and the interaction. And then it's morphed. So this was the initial system. This was 2005, 2006. So this is right when Facebook is coming out, right? So rather than doing something cool like Facebook, I was building educational software. I missed my window for coming up with that $1 billion idea, but hey, I'm still paying my penance from Wall Street, so it's okay. And so this was the initial design. We called it the Clermont Conversation. I did my PhD out at Clermont Graduate University. We used a lot of the different tools, which we'll go into in some degree over the next few slides. The ones that are underlined are the ones we're going to talk about today. So I build recommender systems and look at sentiment. And there's one more there, quality. So I just had a student present last week at SACNES, which is a diversity conference in Long Beach. And she presented on this cool concept, this software concept we came up with over the summer. But this was the original system. So it didn't have the AJAX stuff. Everyone know what AJAX is? It's the ability to click on a link or produce content and not have to do a page refresh. Back in the day when the internet was just out, in order to get new content, you had to download the page again. Now you can click submit, it goes to the server does processing, and it returns back to you new content and displays it on the page. There's no such thing as a page refresh anymore. So if you are on a website that you have to click page refresh, it's just an outdated website, that's all. And it's fine, most of our learning management systems are still a little outdated. Software like that takes a decade to catch up with the technologies. But if you're building a social network, it's expected. You're not expected to click refresh every time. The original Facebook, you ever watch The Social Network, the movie The Social Network? He's clicking refresh on the screen. He doesn't do that anymore. That was in 2006, 2005, 2006 when he built that initial, the Facebook.com. So you had to click refresh. The websites don't do that anymore. It comes to you automatically. So this was the original concept, and then we morphed into more AJAX stuff. So you can click on ratings, and it went to the server, and you didn't have to click refresh. Data came back. And then this was the new theory that we have. Again, we focus on the community, how the community is perceived, how they engage in the technology, and it always is the individual. To start any conversation, you have to remember the individual. You have to remember who you're talking to. At the other end, that's the problem. There's a really cheesy cartoon. On the internet, no one knows you're a dog, meaning that on the other end of it could be a bot, right? I mean, that's the whole Turing test, the idea of a Turing test. Are you communicating with an actual human? You don't really know that. But you have to, when I'm building software, that's all I think about. There's someone going to interact with this data. There's someone going to interact with this system. So there's someone behind it. You always have to remember that. And then this is the newest version of the platform that I've been using, Social XYZ at Channel Islands, that I have my students use almost every semester. Some of the courses don't really warrant a social network, like some of the heavy technical courses, but I still have discussion boards and sometimes blogging assignments to make them reflect on a research paper of some kind. But this is what it looks like now, and we'll go into more depth there. People have profiles, so it becomes more interesting for them. It's not just this cold institutional software, but they can actually take a little ownership, show their Twitter handles or their Instagram, and all these fancy, their Facebook links, and connect to LinkedIn and all these social networks. So the whole point is, it's not institutional software anymore, even though we're at a mental institute. It's not a mental institute piece of software, institutional piece of software. It's more of a social grassroots style piece of software. And what's the difference? So, like, I've been doing this research, and finally, at least Channel Islands and a lot of schools are figuring out, all right, this model kind of works. So, and of course, I'm biased in a sense, but the way I run the experiments, I have a control group and a treated group. The control group is those using the regular course management software, and the treated group is the new social networking software. I run the same exact assignments. I have other instructors run the same exact assignments, use the software, run the assignments, and the experiments are set up identical. They have the same assignments, they have the same expectations, and the differences are, I mean, it's night and day. This is just a social network. I'll talk a little bit more about a sociogram. Not a sociopath, a sociogram. And it shows interactions of a network, interactions of nodes, students in a network. And this is your course management software. This is a social networking software. And if you drill down to other aspects of it, this is perceived levels. People don't like perceived levels because it's students reflecting on their perceptions of a piece of software. But you still need to ask it. You need to ask students, people using your system, do you like it? Did it work? And areas that I ask are, is it tied to the course objectives? Because it's replacing course management software. It doesn't always have to replace your course management software, but I have it as a replacement. And yeah, they say it's tied to course learning objectives. It's easy to use. It's much easier to use. Students are used to, especially millennials, are used to social software, more friendly, easy to use software, much easier to use, and then they have a better experience also. So those are just perceptions of how easy it is to use and how useful it is. And then I ask, did it increase interaction? Because more interaction means more information going back and forth. I do data analytics as well, so actually diagnosing what the conversations are going back and forth is a different story. And that's for later research that I'm working on. But either way, there's a dialogue going back and forth. People are communicating back and forth much more in a social network than they are in course software. The learning is roughly the same. There's no real difference between learning, I found, which is good. I mean, I hope that more learning takes place more perceived levels of learning take place in social networking, but at least that's not the case. But at least it's not less learning. At least they're not saying, all right, well, less learning is taking place. And then I can't use that software anymore, because the whole point of the software is centered around learning. And then it increases community as well. So this is just giving you a background, 15-minute background on all this stuff. It all started with blogging. So this is your Angel blog, which is fine. It's just not what you think about when you go to a WordPress.org or something. Am I familiar with WordPress? My website is WordPress. WordPress is amazing. So many templates, and it's just got a very nice, engaging interface, as opposed to something that's kind of retrofitted into a course learning system. So that's what a blog would look like. And then I started fooling around with Twitter, and this is where things get really interesting. So anyone who's starting out programming or has been a seasoned programmer, the best thing, the most interesting thing, so it's competitive now. It's not enough to know a programming language. You need to know how to integrate with other kinds of systems that are out there. And so just taking Twitter as an example, they have an API. Does everyone know what an API stands for? What's it stand for? Application Programming Interface. So you can interface with a completely different system. Send them requests. They do all the processing for you. Sometimes they charge you. So a lot of times, a lot of these APIs provide you with like 500, 1,000, 20,000 down requests in a day or a month or something like that. But you send them a request and they return you data. So that's how this Twitter thing works for me. If you hashtag social XYZ in your tweet, it will be pulled into my system. I run their API and it brings me this huge JSON feed, JavaScript object notation, I parse it and I display what information I want to display or what data I want to display. So one of the things I fooled around with was, it didn't work, it failed, but it was a fun experiment either way. So I had students tweet in the class, so they tweeted something, and then I pulled it into my system, and then they could start a blog post from it. Anyone's tweet, not just their tweet. They can see a tweet come in and say, all right, I'm going to post a blog based on that tweet. So that failed. But what didn't fail was I now, and the whole reason is that in an educational environment, you need something that's where students feel comfortable. You don't want students doing everything in a public forum like WordPress or Twitter, because this is your education. You're experimenting and learning. So you don't want the entire world to see your learning process, because it could be messy. It's like making laws. And it can be very messy in how you learn. For me, I'm a mess when it comes to learning. I'm a hack. I just, my notes, I'm a terrible note taker. So I don't want anyone to know how I learn, even though I keep on YouTube now. But the point is that, so in this case, I had a student's tweet. The tweets came into the system, and then they can create a threaded discussion from it. So it was kind of fun, and it worked. So that was an interesting experiment. And then do you guys have Capstone Projects here? Yeah, so are you Capstone's group projects? Some of them are groups, some of them are individual. So I was using Twitter as a method for motivation, so how well it motivated people in groups and Capstone projects. That kind of worked too. But this is just one simple slide on the Twitter API. So easy, it's written in PHP, one of the uglier languages, but I love PHP because it's pretty easy to work with. Not my favorite language by any means, but it's still a fun language to work with, especially if you're building web and data-driven websites. So it's super easy. It's like 10, 15 lines of code, as long as you have the key. My key up there? My key's there. That's bad. Blur that out. Anyway, I have to regenerate my key now. Anyway, so it's just really easy to interact with these APIs. All right, so another thing we focus on is, again, this is human-computer interaction. How we can take data that's coming in from a user, redesign a system based on that data. So this is a fun one. This is related to students, because again, students in STEM sometimes have a difficult time figuring out what the core concept is when you're talking about a particular area of technology. So this was, we would have academic papers, and there's a discussion board, and then students would highlight and increase the font size of content or concepts they thought were important. So it's crowdsourcing the important facts of a document, which is dangerous because sometimes students can get off track because they're not experts in the field. That's where the instructor comes in and scaffolds the whole system so they can make things smaller or bigger. And you get something that looks like this. This is just a heat map on top of where people are focusing. And they focus with these types of systems, especially, again, this is learning systems. So it's important to have the discussion guided in a way that's appropriate. So this is just a heat map showing where students are focused in on a particular document. And it turns out with these types of systems, they focus more on the core concepts. That's all this slide is showing you. So that's fun stuff we're doing. Now I want to get into the really fun stuff, and this is kind of what I really love about my field, or at least my area of expertise. So I've been doing it for 10 years, and this is recommender systems. So I love building recommender systems, recommending data. So this is probably my favorite recommender system online. It's Goodreads.com. I think it's .com. It's .com or .org. It just fills it in now. Goodreads.com. The whole point of this system is you put in what books you like, and it recommends you new books based on a simple star rating. You rate the book out of 5. And it'll take all your, it's called collaborative filtering. So it extracts all the things you like and don't like and finds matches from other users who liked or disliked the same thing. And if you haven't read something that that user has read, they recommend you those books. So it's a pretty fun way to get recommendations. It could work with movies, it can work with products. In this case, it works with books. Can it work with students? Well, that's what I started to kind of experiment with. So based on blogs and how students rated blogs and things like that, I was recommending, because I was leaving my graduate studies. We had this social network called the Clermont Conversation. Once I left, the system was going to die. No one was taking over this system. It was my baby. It was my project. So once I was leaving, I was like, all right, here you go. So right before I left, I wanted to see if we can create this thing to be self-sustaining, meaning that the users would keep it going. because without me going in there and posting and egging people on to produce content, it was going to die. So I decided to just build a recommender system. Let's see if I can take the content that people are generating and start making recommendations. Now this is the formula that got me a job. I don't know why it got me a job, but sometimes computer folk, math folk love to see a formula of some kind. It looks like a crazy formula. It's not. You can break any of these formulas down. Everyone knows what a square root is. This E just means a summation, right? And then it just loops through all the products, in this case users, and recommends them users. This is the Pearson correlation. It's not a fancy algorithm by any means. It's a statistical formula. Very easy to break down and program, which I did. And then I was able to recommend users to one another based on their likes or dislikes, based on the blog posts. My dissertation failed. The system is no longer used, but that's okay. I got my dissertation. I got my degree. But I also learned a lot about recommender systems. So what I decided to do later on was, because STEM is I teach in STEM. STEM is a very difficult. STEM has a lot of difficult content that students have to get through. I decided to do a similar approach. In this case, I used the distance formula to figure out, all right, well, how close are two users in terms of their grades? You can break down their quizzes, you can break down their assignments, you can break down their test scores, and come up with, all right, well, there could be similarity indexes, and I want to go with the opposite similarity, meaning that students are doing really well, I want to pair with students who are struggling. So I built this system based on, all this is private data, but students were allowed to update, or actually I did it. I updated their test scores and their quiz grades and their assignment grades, and then I was able to generate recommendations. So the student would log into the system and see who they were paired with, and every week or every other week, they would work with that student on. They would work together on some kind of assignment. That did work. So 83% had provided help. 74% said the classmate interacted with them when they sought out some kind of help. Only 50% were interested in sharing work, and that could be read either way, because if 50% of the class is struggling, then they won't want to share their work for whatever reasons. And then the same way, 43% provided help. Maybe some couldn't provide help because they have a difficult time with the concepts. But anyway, it was just a different approach to a recommender system, recommending users based on their scores, based on their quality. All right, 25 minutes in, we finally get to the new stuff we've been working on. So I'm happy to introduce you. We have this paper that's so based on the work we did last year, over the last couple of years. It's we're presenting it at HICS, the Hawaiian International Conference on System Sciences, in January. It's a great conference to go to. It's in Hawaii. But initially I had it called SAD, and then I decided not and all the posters, presentations that we present, we call it SAD. So I call it SAD here, but in the terms of the publication, I decided to stay away from calling it SAD. But anyway, it's the Sentiment Analyzing Discussion Board, B lowercase, and it looks something like this, and we're going to go through exactly how this thing worked. So it started in 2015 when I first started teaching this internet-based social networking course. So again, as I'm not a seasoned academic, so I don't know everything there is about everything there is yet, but I picked up this textbook, and the textbook was, the basis for this textbook was well, it's on this slide. So Kadushin wrote the textbook. In 2005 it came out. Interaction leads to positive sentiment, generally. These are generalizations, but this is generally the way things work. If you break things down into it works or it doesn't work, interaction leads to positive sentiment, and positive sentiment leads to increased interaction. It's a classic case or a classic game of improv. You know how improv works? What's the number one rule of improv? Anyone know? Number one rule of improv. No one knows. What is it? Oh yeah, well that's what improv is. But you're right. Yeah. Number one rule is don't say no. As soon as someone says no, it's like, because now it's like, oh okay, now you're a kangaroo, and someone's like, no I'm not. Like improv just stops, right? You can't continue on a no. So it's the whole point is say yes. It's the Jim Carrey movie Yes Man, I think it was called Yes Man. The idea of that, and not necessarily that good things are going to happen, but more interactions are going to take place. So that's the whole premise of this argument here. Or, and when I started teaching, it's the number one rule. I'm from New York. It's very easy. Everyone's a jerk in New York. That's not true. But we have a perception of being very hard and cold. We're not. We're all very friendly out there. But we talk very fast, and we have, we don't like when people walk slow. But the number one rule is don't be a jerk. So the whole point is that I'm trying to build this system to have people interact. I want an environment that's that's warm and welcoming for people to share and exchange information. So yeah, so it's this whole positive feedback loop. So the first thing we did, so this was a 3-week research project, 40 hours a day. I was working with 3 undergraduate researchers, and we analyzed, we analyzed historical data and we built a new system, all within 3 weeks. It's amazing what you can achieve if you dedicate X amount of hours. This is 8 hours a day, 8 hours a day for 3 weeks straight. So in 3 weeks, we were able to analyze all this data. So we analyzed 6,000 discussion posts. It seems easy, you can just come up with the positive, negative, or neutral, but there's more to that. We had to analyze it and kind of look for trends and things like that. So we already had this premise that positive sentiment leads to more interaction, but what does the data show us? So looking at the data, actually more interactions leading to more neutral interactions. So it's not yielding more positive. In fact, positive interactions are going down as the number of responses are increasing. So that's as the thread is getting bigger, we're looking at positive, negative, and neutral. It's also true that the negative posts are decreasing, but the whole point was, all right, well, how do we increase the number of positive posts that are being made? So what we did, we came up with this new architecture, all within this 3 weeks. So the new architecture looks kind of crazy. It looks much better on a poster when it's kind of in the corner, and you can explain it. But very simply, in the discussion box, you would type whatever your response is, and we make an API call, a programming interface call to, we use the Mashape, which is this marketplace for APIs, and they allow you X amount of API requests before they start charging you. So I think the first 20,000, is that true? The first, I don't know what the number is, but X amount are free, and then after that they charge a penny. So it's kind of nuts. If you mistime an API, like, and your server just receives so many requests, you can get charged. We were doing the math, and I was like, oh man, I can get charged $200 an hour or something like that. I was getting really worried, but the system didn't take off as, I guess, thank goodness enough. It didn't take off to the point where I was going to be in financial dire straits or something. Anyway, so we make the API call, and it returns us the positive, negative, or neutral. It's based on the NLT toolkit, the natural language toolkit, and that data set is trained against movie reviews. So it's not like a perfect correlation between movies and education content, but we had to work with what we were given, and we had 3 weeks to do it. We couldn't come up with our own sentiment analyzer, although we're working on that now. But once we receive the response, we're able to generate, so this is an example of a student that would post, I know it's blurry, you don't really have to see the content, but they would repost a response. In this case, it was a Radiolab podcast they had to listen to, and they responded to some questions, and then they were able to click on the analyzed text. So the analyzed text would make that API call, pull back the probability of this post being positive, negative, or neutral, and then generate some kind of visual interface for them. So it just showed them, I mean, you're not graded on this or anything, it just gives them some idea of the probability that your post, or how your post may be perceived. So in this case, it's positive. Do they want to post it? Do they want to revise it and click it again? That's the whole goal. Can we we're not saying that negative posts are bad. That's not the goal of this. But maybe students or users, I don't like to use students so much because this is more generalizable than just students, but maybe the user doesn't want it to come across as positive, negative, or neutral. Maybe they don't understand the tone. Like most people don't understand how New Yorkers think or kind of how they communicate. It comes across as negative, but it's not always negative. It's just kind of the way we are. So sometimes when we say something, it's like, oh, I didn't mean you to be offended. That wasn't the point. But we don't have this, we don't have this built into our head. So it's unfortunate. And then we built it into the system itself. So again, this is just blowing it up. So we have a student, and when you're responding to students, you can do the same thing. So responding to the top level thread, you can see, all right, well, how is that perceived? And then when you're responding to your classmates, you can also see how that's perceived. And the goal, again, is to kind of reduce the number of negatively perceived posts and increase with more positively perceived posts. Well, did it work? So we had a control group and a treated group again. That's just that. I mean, those are the actual statistics. So this shows you the number of posts being made and then the number of positive, negative, or neutral. But looking at it in a graph form, so the number of positive posts are actually lower than the number of negative and neutral posts. But we were okay with that in the sense that in this case, negative posts started to go up. So as the thread got larger, the number of the negativity in the thread went up. which is it's counter to what Kadushin says. It's when the thread gets longer, the number of positive posts should go up. But anyway, so what we actually found was we were able to on some level, reduce the number of negative posts while increasing the neutral posts. So the nice thing was, all right, well, even though positive posts didn't increase, negative posts didn't increase either. So we reduced the number of negative posts on some level. So can it all be attributed? We need to do more statistics on it. Can it all be contributed or attributed to the design? Well, we're working on that. And we need to run, this was a small sample set. This is class sizes of 20, in both cases, the control group 20 and the treated group 20 roughly. 19 and 22. So anyway, but what we did find and what we can extrapolate from is the network itself. So we can run, once again, this is called the social network analysis. I run these just about for every one of the courses I do just to see how interaction is taking place. And you can see the control group versus the treated group. In the treated group, you get a much more diverse set of interactions that are taking place, which means more individuals are interacting with more individuals, which is kind of the goal of the system in general. We want people to interact with content they're comfortable with interacting with. And if it's with more users, even better. That means more students are interacting with more students. So we were kind of happy with that. So in conclusion, what did we find? Yeah, sure, it didn't produce greater percentage of positive responses, but it did increase the number of neutral by reducing the number of negative posts. So that was nice. We were happy with that. The new design resulted in a higher average number of responses per user. That's also important. So the fact that people are posting more is big. We want more interactions taking place. So the total number of interactions increased. Again, how much is this attributed to the new design? Well, that's stuff we're still analyzing. So this is just the initial. This is the kind of the prototype and the beta stage of the software. And then users responded with higher levels of perceived interaction and community. So when we asked them for their perceived levels of interaction and community, they felt they perceived higher levels of that. So that was nice also. And then those graphs on the previous slide showed a more dense network. A more dense network means more interactions taking place across more students. So not only are they interacting more, they're interacting with more people, with more students, which is nice. All right, so that was Accesso Project 2015. That's what 3 weeks of dedicated research on in a particular domain can generate. And then this past summer, we decided to work on something different. Eventually, we haven't tested this out just yet. We're going to remove the sentiment aspect of the system and focus on, we came up with a formula for quality. Very simple for providing students with a way to assess the quality of their post. Now, the algorithm, again, fancy algorithm, people love to see these formulas and stuff like that. Very simple. This thing breaks it down on keyword density. So how many words, after you remove stop words like the, and, ors, you remove those first, and then you do a very simple calculation of how many of those words are keywords, meaning are they in the textbook, are they important words? How many of those are keywords divided by the total number of words? So we look at keyword density. So are the words you're producing important or important to the text? And what was the other one? And readability. Is it easy to read? 2 very simple formulas. You break it down into keyword density and easy to read, and it can produce a very simple quality index. So we're testing that out now. It should be fun. I'll be testing it in the spring. This is another thing I'm working on is heat mapping. So I ran this a few years ago, like 3 or 4 years ago, and it was a very simple quiz that had syntax errors in a program, and then you took a quiz by clicking on the syntax error, and eventually when I closed the quiz, students can look at their syntax errors compared to the professors or the class. So you can actually see where the class is finding, I mean, there's some bugs I still need to work out, but they're finding where the errors are, or where they're seeing errors compared to where the class is seeing errors. So not only are you finding the errors you have wrong or are missing, you can see how the class, I guess this is more of an assessment of the instructor than the students, but you get to see are other students missing the same, or clicking and finding the same errors, or not finding the same errors. So it's kind of a fun way, and it's just an interesting way to do programming quizzes. So that's another thing we're kind of working on. Another fancy formula. this is my last one, and I really want to get this off the ground. It's the zombie experiment. So I have enough historical discussion data now to generate fake posts. And I don't know, I guess maybe IRB can tell me whether an institutional review board will review this. Maybe they will, they'll review this and see if it's okay to test out on. But the whole point is it wouldn't say zombie, but it would say like someone's name or something like that, and it would have content. And I want to see if we can dynamically generate new content from historical content and have users interact with it in a way that it's useful. So this is like crazy experiment stuff, but maybe it wouldn't be in the classroom, it might be outside the classroom, but it should be a lot of fun. Again, this goes back to the Turing test. So can students find the fake post, or will they interact with a post that's not based on human generated content? So that should be fun. And then there's a whole bunch of stuff. Once you have, so now it gets into, I've been doing this long enough, I have so much data to work with. So it's a lot of fun to perform different types of experiments because I can leverage different APIs. I can leverage students' ability to build interesting software. So we can come up with new formulas for diagnosing, dissecting the information that's being produced, and coming up with new ways to represent that information. So, not bad. All right. Oh, so our last slide here is just the students I've been working with is Gala, Jose, and Ben. Ben's in my database class right now. And this is Evren. He's an instructor. He's a professor at Bloomsburg State in Pennsylvania. So each one of these are on the paper that we're presenting in January. So I'm pretty excited about that. And that's pretty much it. So stuff we've been working on. And so I got 5 minutes for questions. So perfect timing. I know I go fast. There's a lot going on, a lot I want to show. But that's why I use mostly pictures. Pictures is 1,000 words. And I probably said 5,000 words. So
Questions?
Yeah.
What have you found to be more important for success of something online? Would it be the interactions that are happening on the internet, or interactions inspired in real life based on what?
Yeah, so we always attempt to mirror real life interaction. So the only way that's going to really work if it's VR. Facebook's experimenting with Oculus, Google's experimenting with Oculus. When VR becomes a reality, then we can try to replicate face-to-face in a better way. But right now it's difficult. So you try to replicate face-to-face interaction as best you can. You can't attempt to mirror it completely. It's just not a good approach because you're going to come out with a design that's non-intuitive to a user. So you try to work with tools they're already familiar with. We're already familiar with how discussion boards work. We don't have VR, virtual reality discussions just yet. We'll get there. But that's not the goal of a discussion board. It's supposed to be asynchronous. You're supposed to be able to do it in your underwear at home at 3 in the morning with a beer in your hands. Who knows? The point is that it's not replicating the face-to-face environment. The goal isn't to replicate the face-to-face environment. So, it depends. For in a learning situation, we don't want to. For an asynchronous tool, we don't want to mirror face-to-face communication.
Right. I guess I'm asking more so, which one is more like the actual real-life conversations that people have because of something they saw online versus just starting conversations online?
So, it always seems to be, are you asking why is the conversation taking place?
No. I mean, the conversation, how maybe you'll see something on Instagram or something,
Right.
and then you'll talk to one of your friends in real life. You'll have an actual discussion with somebody.
Right.
Oh, did you see this? Did you see that? Is that more important, or is that something that is able to be looked at?
Both are important.
Okay.
So you're saying, is the artifact they're talking about more important than the discussion?
Right.
Okay. No, they're both important. So sometimes it's not starting the conversation. There's a lot of bad stuff that happens in the world, and they say, oh, we're going to start the conversation on it. The bad stuff, eventually, you don't want to ever say it, but it becomes part of the background. The discussion is what's important. It's what are we going to produce from it. So we have a starting point, a catalyst, some catalyst that initializes the conversation, and then the important stuff comes what we learn from the conversation. Not in all cases. In some cases we're just talking about something that went viral that's funny and interesting, but it's not really yielding to any kind of final conclusions. But the conversation in a lot of cases is as important, maybe more important than the artifact that they're discussing. Yeah. Anything else? No?
Maybe you want to comment on the user temperament.
User temperament. Yeah, so what we found, so we look at the sentiment of the posts. And what you find, or what we found through the analysis, I can go back to the social network analysis, lots of times the negative posts, you know, and not in all cases, but those users that are responding more negatively usually sit on the outskirts of the social network. There's interesting studies that look at, so if you're positive and you have a positive, what do you call it, a positive persona online, you're going to have more interactions, meaning that you're going to have more followers and more people are going to want to interact and be your friend. But if you have a negative persona, and there's a lot of negative personas out there, that's what they do, like whether it's sports or politics, they're just like the negative voice and everything is bad. They have fewer interactions and fewer followers. However, they have a stronger bond, funny enough. They have a stronger bond with who they're following. So people are really more attracted to negativity in a way. So those that are attracted to negativity and are following negativity, there's a tighter bond than people with people that are like, you know, spreading love and happiness and things like that. So it's a very interesting dichotomy. No, I guess, I mean, it kind of makes sense. You're, you know, passionate about something in a way. I don't know, but yeah, no, that's, in terms of temperament, it's pretty interesting. But in our experiments and the systems we've been running, people who are posting negative usually sit on the outskirts of the social network. Which makes sense because people are not going to interact with people who are being negative. They want to keep the conversation going, so they're going to interact on the neutral posts and the more positive posts. But mostly the neutral posts. It seemed like neutral posts were the way to go. And in an academic environment, it kind of makes sense because you don't want to be, you want to talk about knowledge building and information sharing, the topics that are important. You don't want to have too much polarity on either the positive or the negative side. So the fact that neutral ratings went up while positive ratings stayed, positive posts stayed high as well was good. So we were happy to see that. Yeah, thank you. Yeah.
So this is users giving their own feedback manually to your system, right?
Users giving their own feedback. They're providing. No, we haven't analyzed. So I have experts analyzing whether or not something is truly positive or negative. This is the system API returning a discussion post as the probability that it's going to be positive, negative, or neutral. So the API, which was trained against movie databases, isn't the perfect fit. That's why we have experts looking at, there's a lot of posts, but the expert would say, that is positive, that is negative, or that's neutral. So humans would say, yeah, that's positive, negative, or neutral. So eventually, we have to go back and say, all right, we have the content. Is it really positive, negative, or neutral? So, yeah.
The control group it uses what?
The system without the interface.
Without the interface.
The same exact system, but there's no text analyze button. It's just the regular discussion board.
But the expert will say then whether it's positive or not.
We use the same system to diagnose it. So the same API call, we just didn't represent it. So content is positive, negative, or neutral, regardless of whether you have a system that shows you it's positive, negative, or neutral. So we just ran the same analysis on the control group than we did with the treated group. It's fun stuff. There's a lot of really cool APIs and ways to build better interfaces. Just because you build it doesn't mean they'll come, but if you already have a dedicated population with me, I have students that join my class every fall or every spring, and I get to find interesting ways for them to interact. So it's really fun when you build a system and people start using your system. It's so much fun. It really is. So I encourage everyone to build some kind of system, whether it's a mobile app or a website, and see if people come and interact.
So on that positive note.
Yeah. Yeah, thank you very much.